Hello, vanakkam. This is our late code problem, and here today we're gonna solve problem number 560. Subarray sum equals k. This is comes under medium category, and this also comes in a topic of hash map kind of topic. Okay. Given an array of integers nums and an integer k, return the total number of subarrays whose sum equals to k. Okay. So a subarray is a contiguous non-empty sequence of elements within an array. Okay. So take this example one. In this example one, they have given two input parameters. One is nums, which is array of numbers, and another one is k, which is just an integer. Okay. So and the output they are expecting to return as a integer. Okay. So in this problem, what you're gonna see is in this problem what they're expecting is they would give an array of numbers, right? uh, you need to take you need to sum it up one by one, and you need to get k's equals value. For an example, this is our array. In this array, if you add up this first two numbers, you would get equal to k, right? So this is 1. This is first group which gets k's value, and second and the third one also can return you k's equals. Okay. So we have two group which can make equal to k, so you can return the 2. That's it. In this case, you can make 1 and 2 as 3, and 3 alone also can make equal to k. So here you have 2, and here you cannot consider this 1 and this 1 as 2 because they have mentioned contiguous number should make this k. Okay. So that's it. We'll jump into the analysis and we'll solve the problem. In this input, we need to find how many groups can make k. Okay. So as a human, when we see it, we can find this is one group and this is another group can make it k. But how we can achieve it in programmatically? As a beginner, you can use two for loops here. One for loop should start from this one, and second for loop can start from just next to the first one. Okay. Just I'm naming it as I and j. So if it makes the k number, then actually you don't need to keep this j here. You can keep this j here, because one number also accepted. If we have two in this index, then we can take that also. So k also you can keep it in same place. You can start from here. If there's 2, then stop there and return at the count. So j is here. We found it. We have 1. Okay. So I'm just adding 1. This 1 is lesser than this k. It is not even equal to the k. So I'm just moving j one pointer ahead. Here when I make it, I have 2, so it is equal to k. So I can stop there, and total is total I can increment to 1. Now I have found it, right? Now remove this I and move one step forward. Okay, J also should be same place of the I. Now do the same process again. I is J is currently 1, and move the J one step forward, and here also I have 1, and when I'm calculating it I have 2, which is equal to K. So I can stop there, and I can add the total 2. Okay, uh, now I'm moving this I one step forward. Here I have found 1. I'm moving J, but there's nothing, right? There's nothing to move, so just stop there and return this total amount, total value at finally. That's it. So this is a naive approach which always beginner use, but in this case we need two for loops, right? We need two for loops necessarily. So this for loop would take order of n time complexity, and this for loop as well order of n time complexity. So totally it would take n square. So mm, as a beginner you can try it out, but we can make it simpler, we can make it more efficient comparing to this. So we'll solve that way. Okay, um, now we'll start that efficient approach. Last time what we noticed, we had two for loops and one for loop. uh, Two for loops starts from the same place, and one second for loop goes forward, right? So first for loop when stays at the same place, and the second for loop moves ahead. So but starting point both were at the same place. So then why we can't have only one for loop? For an example, here I have one for loop I. Okay, this I going to have, yeah, before that I need a hash map. I'm going to initialize 0. Okay, 0 as 1, because I'm going to take that value count is 0. Now I don't have any counts, right? For example, total is 0. Now I didn't make any count with these numbers, so total is 0. So I'm having 0 as 1 as a value. Okay, now I'm gonna have count as well. Count is going to have 0, same. Now I'm just starting. I points to 1 and value is 1, so total is 1. Total is 1, and after I found the total, I need to apply with one logic, that is total minus k, and check in this hash set. I just have it as a store. Check is this value available in store. So here I have total is 1 and k is 2. Here we have minus 1. This minus 1 not present in the store, so ignore it. You don't need to proceed further. Ignore it. And meanwhile you should do one thing. You should add this current value to this hash set. Okay, now what's your value? Your value is 1. Total is 1. So add the total and add the previous value. Previous value means if this value um, is not present. If this value is not present, just have 1. Okay, if this value is not present in this hash set, I mean this value means this value, this -1 is not present in this hash set, so I'm just adding 1. If it's not present, then you can add 1. If it is present, then you may need to get the previous value plus 1. Okay, now this value is present, then I'm just adding not present, then I'm adding 1. Okay, now move this pointer one step forward. I is here now. Here I have 1. Now the value total is 2. Total is 2, and here I'm going to check with this value. Total is 2. Here I got 0. So the 0 is present in the store, right? If the 0 is present, then just store the value. Actually, before storing the value, you need to do one additional step here. The value is found. Okay, now take this count. Count is 0, but you need to take this zero's value. We found 0. 0 is present in the store, so zero's value is 1. So you can take this zero count as a 1 now. Okay, then add this value 2, and this value is already present. This value is 1, so have it as 1. Okay, because 2 is only once, we have 2 only once, so that's it. And move this pointer one step forward. Here we have 1. Total is 3, and total is 3. Here I have 1. This 1 also available in our store, so the value is 1. So take a count 2. After, here you need to add this value with 1. Okay, that's it. So finally we've reached at the end, so there's no way to move forward. You can end up and return this count as an answer. That's it. Okay, I hope you would got it. If you didn't, then we'll code it in the PyCharm, and we'll debug it in one by one. We'll debug it in step by step. Maybe you will get there very easily. Okay, we'll meet there. We have written our code, and here I have a bank store. Here this is 0 and 1. 0 is a key and 1 is a value. Count is 0, total is 0, and I have one for loop, and I have a total. Here I'm adding one by one, and I have an if condition. This if condition checks set logic, and if it presents at present in the bank store hash map, then we need to do one additional step, which is for adding the count. And after the if condition, I need to do one more thing. We should add the value to the hash map. Okay, now here is the return statement. This is my input now, and here I have a k equal to 2. Okay, let's debug it, and line by line. Okay, debug pointer is pointed to the 4th line and coming down. Okay, we have reached the for loop, and I is 1, and if you see here, bank store has 0 1. Okay, and I is 1, total is added up, and if condition won't be get executed because it is -1. -1 is not there, so we don't get executed. And we are going to add this value to the bank store. we have added. Okay, this is the logic actually. In this logic we are getting the value from the bank store. If it is present, then we are getting that value, otherwise we have a 0 as a default value, and we added 1. And while coming down, um, another one has added to the total. This add up made a total as a 2, and which is already present in the bank store, so it executes one another additional step. Then yeah, we are adding the count has been upgraded, and we have added the total 2. Okay, and now total, yeah, total is 3 now. And when we are checking that, 1 is already present, 1 has 1 as a value, so we can add the 1. Finally we came to the return statement, and count is going to get return it. Yeah, count has returned it. We got our answer as 2. Okay, that's it. Okay, last time when we saw that that naive approach would take order of n square time complexity, but in this case it takes only order of n time complexity, because we are going to use only one for loop. And but last time it didn't take any extra spaces, but here it takes, because we have a bank store has set, it stores each uh, steps value and key as well. So this is the time and space complexity for it. Okay, we'll execute the same code in our lead code, and we'll find, let's run it. Okay, it seems like it works as expected, and we'll submit. Okay, it works. Okay, if you wanna see, you can check the analyze complexity. It will take order of n time complexity and order of n memory space complexity as well. Okay, that's it for this video, and let's meet on the next problem. And planning to make some other additional series as well. I'll plan and execute those simultaneously. Okay, thanks. Until that, bye.